I see a really, really small K value. But is this what I look at to know if I can neglect the
No, like I think it's
power?
a comparison between like the thing and the.
Here's what you would do. You would take the K value, and you see how this, when it dissolves, makes 5 ions, 3 of those and 2 of those. Take the fifth, whatever number of ions are made, take that root of the K value. The fifth root of that is going to be 10 to the negative 6 point something. So that's still less than 10 to the negative fifth. So you can neglect the plus next term. Yeah.
Like on the quiz, we'll always use the 5%.
I'm pretty sure that I wouldn't expect you to be able to solve for x to the fifth polynomial. Yeah. And you'll see in the problems for homework, you won't have those crazy calculations. Any other things about this? Were you able to get that x value? Yes.
I got. Wait, I did what you. Oh, never mind. Sorry. I think I divided by 37.
Got it? Okay. Okay. All right, now we're going to go and take on something new. Now this new thing is going to reintroduce a topic that we've talked about a couple of times now this year, the idea of Q, the reaction quotient. Q is a calculation that looks just like K, but Q is calculated when the reaction's not at equilibrium to kind of give us a status on where the reaction is. So when you have to deal with combining solutions of everything dissolved, and when you combine solutions, you might form a precipitate. Depends on what the concentrations are. So this is the guideline for how we know whether a precipitate will occur.
So
You have to use the Q value. Yes.
On the quiz, we had the 1 minus x over x, and you couldn't neglect that minus x. Is that because it was a log?
That's because you weren't using a K expression. You were using actually the buffer equation. It was the log of the quantity x over 1 minus x. So you have to do the algebra in that case. X is not small enough to neglect in that case. That's why. You only neglect it if it's a tiny and it doesn't change that value of the constant. So you kind of programmed your mind, and every time you see a minus x, you neglect it. Yeah, that's not always true. Okay, it's 10:52. Well, I have time for one problem. Yes.
What if Q is equal to KSP?
What if Q is equal to KSP? What would the reaction do if Q equals K? That means that it's at equilibrium. It's not going to shift one way or the other. So that is the desire of a reaction, is to get its Q equal to K, because that's the position of most comfort for a reaction. So I'm going to say something. I want you to listen very carefully to it, because this is going to be counterintuitive to you as you write some chemical equations. When you have any kind of a problem or a situation where you are dealing with something dissolving into ions, I want you to always write your chemical equations in this chapter with the solid on the left and the ions on the right. And there's going to be problems where you're given you won't have any solid to begin with. You're just going to be given concentrations of ions, and it's going to ask you if a precipitate forms. Well, you still need to write the equation like this, because you're going to be given the ion concentrations. You're going to think, okay, it's going to make a precipitate, so the precipitate is going to be the product. Yes, the precipitate is going to be made, but I want you to write them like this. And the reason that we do that is because we have a KSP value for whatever this reaction is. It's got a KSP. And the KSP assumes that the ions are on the right. So it's always going to be that times that divided by 1, because that's not aqueous or gas. So because of the way KSPs are written, I always want you to write the equation like this. Even if you're given these to start with and the reaction goes to the left, still write the equation like this. And I'll remind you of that as we go through some of these examples, because like I say, you're going to get to problems where you're going to want to use the ions as the reactants because that's all you're starting with. Just write it like this anyway.
What's that amazing skill?
Okay, so let's take a look at, oh gosh, it's 10:54.
That's Friday.
All right, we'll pick this up after lunch.
Hey, yay, yay.